Hi, welcome back, Code Emplacers. This is Trevor Balent, and I'm one of the section leaders that was helping you through this course. And today I want to talk to you about an advanced topic, version control, and specifically the tool Git that we'll use to uh, introduce the topic of version control. It's the most popular one, so it's a natural choice. The basis for the slides was set by a fellow section leader, Andrew P., so thank you, Andrew. And let's go ahead and get into it. So first we'll discuss version control. Why do you want to do it in the first place? Why is this so important? And hopefully, since you've been working on your final projects and finishing them up, you'll see by the end of this that this really would have helped you, and that'll make you really excited to use this going forward. Then we'll talk about Git basics. There's two major topics we'll be talking about, repositories and commits. As soon as we talk about those, we'll go straight into creating a repository in PyCharm and how to commit in there. And then all of this is great because we're doing it all locally, but how do we share our work with the world? You'll need to install Git yourself from a link like this one. So once you have it installed, you need to go to PyCharm, click File, Settings, and under Version Control, go to Git. And then you just need to set the path to executable here using this after you've installed Git, and you click Test, and it says, hey, I know what version this is. So if that works, then you're good to go with Git. So why do version control? So look on the right. Have you ever had code that looks like this? Final project 2, final project 2 again. So how do you know where we're working now? And more importantly, how do we look at our history and say what was working when, what was broken when? And if we showed this to our boss would say, where are you now? What has happened and when? You may have already used version control in Google Drive because you could save multiple versions of a file in your Google Drive folders. The point of version control is to have a clean history of what's been done. So up here in the top right, we'd have this final project.py, and that's all you'd see. You'd have to go into version control to see all of the changes that have happened. So the folder is cleaner, and you have a clean, detailed history of what's happened. Another reason to learn it is that if you're going to end up doing code in your new roles, pretty much everybody is going to use Git to control what's happening with your code. So it's good to learn for that reason as well. So the basics of Git, repositories and commits. A repository, or repo, is a collection of version-controlled code. You could think of it like a folder. Now, like we saw in the last slide, you could use version control for code. You can use version control for documents. You can use Git for books, actually. People use it for books and data, actually. The Johns Hopkins COVID-19 data that's at this link is a Git repository. And if you look over here on the right, this is what it looks like. It's a folder with these 5 things in it. 3 of them are folders, and those have a bunch more files and a bunch more folders in them. And that's where you can get the data for the Johns Hopkins COVID-19 data. So you can store all kinds of things up there. It's useful to store code. The Johns Hopkins has no code up there, by the way. It's all just CSV files. The other main thing that we need to talk about is a commit. A commit is a record of a change. It includes who made the change, what exactly is different from the last commit, when the commit happened, and a brief description. So those first 3 things are automatic. When you click the commit button, it says, Joe is clicking commit, and these are the things that changed from last time, and it's happening at 1:40 p.m. And then you have to provide a description. So over here on the right, we have a list of commits from the Johns Hopkins Git data. And the first line here is the detailed description, or the brief description. And you see it happened 4 days ago for these, 4 and 5 days ago. Adjustments to Spain recovered. And if you click that commit, then you'd go in. So this, you're seeing the who did it, when it did it happen, and their brief description. The what is, if you click one of those, it'll go in and say, these lines used to look like this, and now they look like this. So it'll tell you every file that's changed, what are the detailed changes. And we'll come back to that after I show you a little bit of PyCharm, but it shows you all of the changes that have happened since your last commit. So let's go ahead and get to PyCharm. This is, we'll just dive right in. So we'll set up a repo and then commit some code. So you probably recognize this from a few weeks ago in section. This is the section filter where we were implementing the Narok filter. And the idea of the Narok filter is we go to every pixel in the image And if the brightness of the pixel, meaning the average of the three red, green, and blue values, is greater than 153, this constant that I've already set here at the top of the code, then if the pixel is bright, we apply the filter. And so right now, this code is basically like our starter code. It has the main idea and a few things, and as well as our pseudocode in it. So let's import this into Git. So in PyCharm, you could do this by going to VCS, which stands for version control, and you'll do import into version control, create Git repository, and select the directory where the repository will be created. You can create it right here. So this is in my GitHub demo project. I'm going to create it right here in the GitHub demo folder. Press OK, and it's going to think a little bit and do a little bit of work to see what's already been done. And now you see all of these files on the left have turned red. Now, the red files mean that they haven't been added to commit. They haven't been staged. You haven't told Git, I want this to be in the next commit. That's what staging means. So what we can do is add this section filter is the code that we're working on. If you right-click it and go down to Git and click Add, or there's a shortcut for that is Control-Alt-A. What that does is it turns it from red to green over here on the left. You see it's green now. And let me just add simple image as well, since we'll need that in our repository. It's green, which means that the next time you decide to make a commit, everything that's green will be included in that commit. Everything that's red won't. So you see here, I have all of these final project things. I've condensed that into this section filter, and we'll say that this is going to be our first commit for section filter. I also am including simple image since section filter imports simple image. So we'll need that in our repository if we share it to the world so that people can automatically run our code without having any other issues. So what we can do now, since we have our whole environment set up, is we can make a commit. We can make our first commit. So you can go to VCS up here again, and you could, right here, commit. And the shortcut is Control-K. One of the more important shortcuts in PyCharm, Control-K. So at this point, our whole environment's set up. We've made a bunch of changes already because we spent 10 minutes writing this pseudocode, and we set up our folder and simple image and all of that. So we'll go ahead and commit. So it's refreshing to make sure that Git knows everything that's changed. And here we see that only the files that we chose are in the commit, and now it's asking us for a message. So you want a message that's informative, but without being too detailed, because remember that everything, Git is going to keep track of every line in every file that's changed. So you don't need to say added comments to line 11, added show image to line 13. That's all taken care of. You need a very high level, but still informative version of what you've done. So I can say created initial code with skeleton pseudocode. And that's a decent commit message. And then at the bottom, we just click commit. And now we're telling Git, again, we're still working entirely locally. We're telling commit that we have a benchmark there, that's where we've set a point in time that we can always look back at and go back to and compare ourselves to. So let's do a little bit of work in here, right? Oh, by the way, on the left, you see that those are now white, which means that they're not staged for commit. And so they're like everything else. Nothing is staged for the next commit. But those are not staged, and they haven't changed. So that means they match the most recent version that's the last commit. And if you go down here, actually, there's a new tab down here called Git. And this will tell you, if you go to the log, that I have this initial code commit right here. And it tells me all of these details about it. And that'll be more interesting in a second. So let's do a little work in here. Let's say I know that I'm going to need a function to do pixel brightness. And I spend a little bit of time doing some work. For the purposes of this video, I'm just going to paste this in. But we know that loop through all pixels is going to be for px in image. And we determine if pixel is bright. We're going to say brightness equals get pixel brightness px. So that's all we've done so far. And we've tested this. Somehow the tests aren't in this code right now. And we know that we've gotten to another milestone in our code. Now, I've only spent a minute since the last commit, but if you were doing this in real life, this would have taken 5, 10, maybe 15 minutes to get to the point where you had another milestone done and you're ready to say, okay, I'm ready to save this, I'm ready to commit this, and say this is another milestone. We're not ready to apply the filter yet, but we've gotten to the point where that makes sense. So again, we can commit by hitting Control-K. It does another refresh. So you see this is blue now because it is staged and it's changed since last time. And the interesting thing here, make this a little bigger, is you see that only that one file is staged. It has my old commit message, which I'm just going to get rid of. But you see here this new section at the bottom. It has a record of what's changed since last time. So remember, we just had this code last time. And now over here, it's going to say, oh, you added this now. So all of this is where line 16 used to be. And if we scroll down, we say, oh, you added all of this between where line 22 and 23 used to be. Interesting. So that's what I mean when it says it keeps track of every little detail. So our commit message this time could be something like added function to calculate pixel brightness. And we'll go ahead and commit that again. Give it a second to do that. And now you see this log, it's keeping a record of all the things that we've done. So we created this initial code, we added a function to calculate the brightness, and now we're going to do our last 15 or 20 minutes of work getting to the end version of the code, and I'm just going to copy paste that in. So you see here, pixel brightness equals this, and then we check to see if it's bright, and then we apply the filter. You should have seen all of this code before, so I'm not going to go through the code itself, but the idea is that we got to another benchmark. We got to the point where our code is working, it's doing everything we expect, and we tested it a few different ways, and we're ready to say, okay, it's time for a commit. So we're going to hit Control-K again. I'm just going to get rid of this message. And once again, so nothing's changed down here at the bottom. I just got rid of a couple of blank lines. And up here, we have this new loop. So it used to say brightness equals get pixel brightness. So I've renamed that in this version. It's now pixel brightness equals get pixel brightness. And it has this if statement where it actually applies the filter. So we've done all that. We can see the change that's happened. The commit message is function to apply Narok filter completed. Yay, we finished our project. So we commit again. It's going to take a second to refresh, and then it'll pop up down here again. So now we've done 3 commits, an initial commit, a midway point, and then the final project. And so what do we do now? So all of this is still local, but you get the basic idea of this keeps track of your history so that you can go back and look at it at any time. I'll take a break here to say, committing is not like saving. I'm neurotic, so when I'm using PyCharm, I'll write a line of code and hit Control-S, which is completely unnecessary because PyCharm automatically saves all the time anyway. But committing is not like that. So save all the time when you're working on something, but commit a few times an hour. So commit when you reach some sort of milestone, when a new test works, when a bug has been fixed, something like that. So commit when something works. So when something that didn't used to work works, or when you have something new that works. That's the idea. So it should be a few times an hour, probably no more than 5 times. You don't want to present your boss at the end of the day with a list of 92 line changes that you did. You say you want to prevent it with 10 or 12 changes that say, I wrote this function, I fixed this bug, sort of things like that. So committing is not saving. So let's move forward. So let's go to collaborative version control. So this is, we want to share our code with the whole world. We're going to use GitHub for this example, but Git is what you'd use to actually do the version controlling. GitHub is just one place to store your code. There's other options like GitLab, Bitbucket, SourceForge. There's dozens of others. So we need to set up this remote destination. And like I said, I'm going to be using GitHub. So you need to create a new repository in GitHub. So this is what that screen looks like. So I'm going to call it code in place test, and that's available. You can give it a description if you want. I'm going to make this private, actually, and leave all of these options blank. It'll make your life easier for the next step. So then you hit create repository, and it takes a second, and it's done. So this is completely empty though. So this is what GitHub looks like, but this is a completely empty repository. So what we have to do is copy this link that it gives us that says this is where our code is going to live once we put it into the cloud. And we come back here, and now we need to tell, so that's a remote destination for our code. Now we need to tell PyCharm where that remote destination is. So if we go to VCS and Git, and all the way down here at the bottom, it says remotes. So then you click the plus here. Go ahead and keep the name as origin, that's fine. And you paste that URL in here. And at this point, it may ask for credentials, but I think I should be okay because I think I have Git set up. And we're all good. So we have set up our remote now. So now GitHub, or PyCharm knows that we have a place to store this code in the cloud. So how do we get it there? Go back to our thing here. So we've set up the remote in PyCharm after we set up the empty GitHub repo. And now we're going to make like Salt and Pepper and push it. Now, it's probably dating me as a reference, but every time I push my code, which is what it's called when you take your code that's on your local machine and push it to the remote repository, it's called a push. Pretty logical, but that song goes through my head every time that I do that. So how do we push? You go back to VCS, you go down to Git, and you do push, which if you remember, commit is Control K, push is Control Shift K. And what that's going to do is it's going to say, what's the difference between what's on this computer and what's on the remote location? And since there's nothing there, it's saying, okay, we're going to take all three of these commits and push them up. And then all we have to do is click push. And hopefully in a second, this will be finished. So it says pushed master to new branch. So if we go back to this GitHub that was empty just a second ago and hit refresh, bam. We have the two files that I uploaded. We can see here that there's been 3 commits that happened. If we click that, we see when all of the commits happened. Notice it's when the commits happened, not when the push happened. So you have a record of what you're doing, even if you only push once a day in your actual job, your boss will still be able to tell you we're working the whole day. So for example, so all of that's up there now. So that's pretty much it. So there's so much more to get. So one of the things that is important is a pull. So if there's been changes to the code in the cloud that don't reflect what's on your machine, if you do a pull, it takes those changes that are in the cloud and puts them on your machine. It's the exact opposite of a push. It works exactly the same way. There's also the idea of branches. So if you, on the left here, you have this code that's working and you have this code that's working, and you want to add some new feature, you don't want to break the code that's working. So you leave that code alone and create another branch, and you could say, I'm going to do all my work over here. I'm not going to mess with the things that are in production that thousands of people are using. And then once this is done and tested and bug-free, then you put it in and you make a release and display ads for your users and all of that fun stuff. So we don't have time to discuss those here, but that's sort of the bigger things that you'll get into once you start working with this at scale. So just a quick review of what we learned. So version control, why you do it? Because it makes future you and your future boss happy. You can see a record of what you've done, and you can go back and see all of the changes that happened. So you can go back and say, this change happened here, and that's why this thing broke down the road. So it's easier to go back and say, okay, change this 2 to a 3, and then we're good to go. Git basics, you know, repos and commits in PyCharm, Control K, that's how to commit. Creating a repository in PyCharm, you know, commitment isn't so hard. It was pretty quick to do that. And linking your work to the world, use remote control to do that. So thanks for coming along on this. I hope this proved useful. And with the experience of your final project, I hope that you will use this going forward or use this to finish your final project if you haven't, and This also lets you easily share your final project with the world with the steps that we completed here at the end. So thanks, be well.